Hello everyone, welcome to the Unacademy. Dear friends, am I audible? All of you. Please tell me, am I audible or not? Okay, dear friends, let's crack GATE ESE with India's largest online learning platform. Get the plus subscription now and start your preparation with India's best educators and with unlimited access and the recorded video lectures. So, myself Ajay Das, I am MTech in Computer Science. I have a teaching experience of 8 plus years. Till now, I have mentored almost 20,000 plus engineering students for the GATE as well as PSUs and work as a freelancer in many reputed institutes of India. Also qualified the GATE exam 5 times below the AIR 500. Also qualified the Chhattisgarh State Electricity Board exam with the AIR 8 in 2010. So download the Unacademy learning app and start your preparation sitting anywhere anytime. लेट नहीं करना है दोस्तों, अभी का अभी डाउनलोड करिए and start your preparation in a proper manner. Okay, so what you will get, this is the major question which is always used to arise in everyone minds. So first thing, you are going to have a daily life classes. Second one is the structure courses, live test and quizzes, unlimited access. So these are the things which is available in in plus courses. So my dear friends, today I will tell you about the new courses, that is the iconic courses. So let's see, learn with the top educators. So these are the educators which I have mentioned over here. These are only the few educators. If you want to know about more thing about the educators, what you can do, you can download the Unacademy learning app, and according to your branch you can view all the educators available to teach you. So don't be late, just download it now. So these are the educators from the mechanical and electrical. My dear friends, I am again and again telling you, these are only the few educators which I am mentioning over here. There are more many educators in each branch by which you can have a learning process in future for the competitive exam. So under the GATE ESE, there are various branches. You know that an Unacademy, for which brand the Unacademy is offering you for the GATE and ESE preparation is already mentioned over here, like the mechanical, computer science, electrical, civil, electronics, production and instrumentation and so on. So let's come over here. This is the major thing which you have to understand. See, the Unacademy is offering two different kind of courses. One is the plus, second one is the iconic. So right now I am talking about the plus. My dear friends, if you are looking for the 1 month of subscription, your plus courses fees is 5,500. Similarly, for the 3 months you have a 13,750. Similarly, if you are looking for the 12 month of course, then your fees will become 40,250. Similarly, if you are looking for the 18 month of subscriptions, your fees will become the 38,500, and for the 12 month 24 months it will become 44,000. In all the situation, whatever the subscriptions you want to take, in all the situation you will get a minimum 10% discount if and only if you will apply the code IFA. You will get the minimum 10% discount. So just imagine your fee structure is this. So once you will apply the code IFA, your fees will become 39,600 after the 10% discount. Are you getting my point or not? So in all the things, means if you are looking for GATE 2021, I will suggest either go for the 6 month or the 12 months. But if you are looking for the GATE 2022, then go for either 18 month of subscription or 24 month of subscription, because there is no vast difference in the fees. So according to your planning, you can choose for the subscription. But while taking the subscription, never forget to use the code that is mentioned over here, that is the IFA, to get the minimum 10% discount. So now again, already I have mentioned the fee structure of the month wise and year wise. So after the 10% discount, these are the fees just after the discount. In 1 month, 3 months, 6 months, 12 months, and similarly in 18 months, and similarly in 90 months. But this discount will be applicable whenever you will apply this code. You will get the minimum 10% of discount. Okay. Now let's come to the iconic course. So here, my dear friends, I'm going to explain you about the iconic courses. So in iconic course, along with the things which is available in the plus courses, they have add on some new features. What are those new features? I will explain you very clearly, but let's see the fee structure in case of iconic course. So if you are taking the 12 month of subscription, your fee will become the 45,000, and if you are taking the 24 month of subscription, your fees will become 60,000 in case of iconic course, because this is the course having additional features. So just see over here, what is the features in case of iconic and what is the features in case of plus. So my dear friend, basic plan to get you started. So in the plus courses, of course, you are getting a best educators, interactive live classes, and structure course and PDF, and live test and quizzes. So these are the things which is available in case of plus courses. But if you are going for the iconic course, then all the things which is available in the plus courses also available in this case. India's best faculty, live interactive classes and structure courses and PDF, live test and quizzes. Apart from that, what is the things which is available? Please try to understand. The personal coach. You can choose your any one of the personal coach who will guide you time to time regarding your preparation, and personalized test. You can have a personalized test by which the analysis will be done. Again, study planner. Time to time, a person will guide you what should be your plan for the study. Okay. Now, preparatory study material. So you are going to have a study material along with all those things. So these things you are getting in only how much? 60,000. Again, my dear friends, it is not a 60,000. Once you will apply my code which is written over there, that is the, you will get 10% discount. This is the minimum discounts you are going to have, and your final fees will become 56,000. Okay. So for any clarification about the iconic or the plus courses, you can personally contact me in my telegram number, that is the 92649545. That fine? Okay. Now see, let's crack it. Already, my dear friends, in the yesterday class, I have told you that this is the flow control protocol, which is the chapter of computer network, and this is the part 2. If you have follow up the earlier classes, then it will be quite easier to understand all the concept that I am going to discuss in my today's class. So let's start. So in my previous class, whatever I have covered, please try to understand in a short form. See guys, in the previous class we have discussed the and wait stop and wait. In case of stop and wait protocol, the channel utilization we have calculated as TF upon TF plus 2TP and plus T of. Okay. Now the same channel utilization will become TF upon TF plus 2TP if T of acknowledgement, if the transmission time of acknowledgement is tending to 0. So just remember these two different formula in case of stop and wait protocol. So my dear friends, what is the eta over here? This is the channel, or you can say link utilization, or you can say the efficiency. So this is the channel utilization, and any utilization can never be a more than 100%. So the value of eta always lies between 0 to 1. The value of eta is always lies between 0 to 1. So this is the first thing which we have covered in the yesterday class. The second thing was the throughput. Okay, throughput is also sometimes called effective data rate. Effective data rate. And how we have calculated the throughput? The throughput, that is the effective data rate, is nothing but this is equivalent to eta into r. So my dear friends, what we are realizing from here, the effective data rate, it is called the effective data rate because it comes due to the effect of channel utilization, because the effective data rate ultimately depends upon the channel utilization. So here RE is the effective data rate and R is the actual data rate. R is the actual data rate. And the effective data rate, or you can say that throughput, can be written in this form: L upon TF plus 2TP into, TF plus 2TP. So you can write the effective data rate in this particular. If T of ACK we are assuming tending to 0. So in my yesterday class we have derived two different things. One is the channel utilization and the second one is the throughput. And here I have told you that TF is nothing but the transmission time of a single frame, which is L upon R, and TP is the propagation delay, which is nothing but distance between the link divided by speed of signal. So these are the formula which you have to remember while solving any kind of numerical, and various numerical was asked from this particular topic in your GATE exam earlier. Okay, now it's time to move to the flow control protocol of sliding window protocol. Okay, see over here. Now today I am going to discuss about the sliding window protocol. Sliding window. Just see over here. Now in stop and wait protocol, we have seen if there is a sender and there is a receiver. There is a sender and there is a receiver. And sender is sending only one frame at a time. The sender is sending only one frame at a time. And due to this reason, suppose the size of this particular link is 100, out of which we are covering only 20% of this area. So in this situation, the link utilization will become 20%, and this is not a useful idea. This is not a useful idea, because what is our ultimate objective? Our ultimate objective to transmit, to deliver more number of data in minimum time. What is our ultimate objective? Our ultimate objective, this scenario I am talking about the stop and wait, and we are trying to fetch the drawback of the stop and wait so that we can move to the another protocol. Are you getting my point or not? We are just trying to find out the drawback of stop and wait protocol so that we can move to the another protocol, which is nothing but the sliding window protocol. So in this scenario, what is our ultimate objective? Our objective is to deliver more data in minimum time. In what? In minimum time. Clear? We have to deliver the more number of data in minimum time. So if the sender is sending only one frame at a time, in that situation link utilization can never be more. So to utilize the link in a full efficiency, what the sender has to do? The sender has to transmit more number of frames at a time. So just see the another situation. This is the sender and this one is the receiver. So the sender can send more number of frames over here. So in this scenario, the link utilization eta is almost equivalent to 100%. So this is our objective. This is our objective. Once you will utilize the link more efficiently, the more number of data will be delivered to the receiver. Yes or no? In the same time, the more number of data will be received by the receiver. So to achieve this, what the sender has to do? Sender has to transmit frames back to back. So now the question is, how many frames the sender will send back to back? Here the question is, how many frames sender will send back to back. This is the major question. Okay, and accordingly what the sender will do, the sender decide its window size. Take example. Suppose the center window size is 6. Here how many frames we are sending? This is the frame number F1, F2, F3, F4, F5 and F6. So if sender is sending the 6 number of frame, the channel is utilized in its full efficiency. Yes or no? So here the window size of the sender will become how much? 6. Because if the sender will transmit more than 6 number of frames, then the frame will get lost. फ्रेम क्या हो जाएगा? लॉस्ट होना शुरू हो जाएगा. बिकॉज यू हैव टू मेंटेन द फ्लो. सपोज आप इमेजिन करो एक सिचुएशन को, 2 बंदे खड़े हैं, ठीक है ना, 2 बंदे इस तरह से खड़े हैं. ओके, जस्ट इमेजिन अ सिचुएशन. अब ये बंदा क्या कर रहा है? बॉल को फेंक रहा है. ये बंदा बॉल को फेंक रहा है. पर्सन ए जो है वो किसी बॉल को फेंक रहा है पर्सन बी को, ठीक है ना. इट इज थ्रोइंग द बॉल. तो अगर आप एट अ टाइम एक बॉल फेंकते हैं तो वो बंदा इजिली कैच करके अपने बफर में स्टोर कर लेगा, अपने बॉक्स में स्टोर कर लेगा. और अगर आप बैक टू बैक 2 को सेंड करते हैं तो भी वो पकड़ करके अपने स्टोर में, अपने बफर में स्टोर कर लेगा. लेकिन आप बहुत सारे बॉल्स को एक साथ बैक टू बैक भेजेंगे तो क्या होगा? सम बॉल ही इज एबल टू कैच एंड able to store inside its box and some of the ball will get miss का मतलब होता है lost हो जाना. Means if you are not maintaining the speed of flow then the packet will get lost. So same thing happen over here. जो कैपेसिटी है 100% एफिशिएंसी का, उससे ज्यादा फ्रेम सेंडर कभी भी सेंड नहीं कर सकता. Now the question is how to find out what should be the sender window size. How to find out what should be the sender window size? Means here I have written the sender will decide its window size and how it will decide. So just look upon each and everything very carefully. See my dear friends, in case of stop and wait, ये stop and wait से ही connected है, इसीलिए मैं इसके टर्म्स को यूज कर रहा हूं. इन केस ऑफ स्टॉप एंड वेट द चैनल यूटिलाइजेशन इज, जब हम लोग n इक्वल टू कितना कंसीडर कर रहे हैं? 1. भाई स्टॉप एंड वेट के केस में सेंडर एट अ टाइम एक ही फ्रेम सेंड कर रहे हैं तो सेंडर का विंडो साइज भी क्या होगा? 1 होगा. तो जब विंडो साइज 1 है तो चैनल यूटिलाइजेशन क्या हो रहा है, TF अपॉन TF plus 2TP. Here I am assuming in case of stop and wait, sender window size n is equal to 1. क्योंकि स्टॉप एंड वेट प्रोटोकॉल में क्या होता है, द सेंडर विल ट्रांसमिट अ सिंगल फ्रेम एंड इट विल स्टॉप एंड इट विल वेट फॉर द एक्नॉलेजमेंट. आर यू गेटिंग माय पॉइंट और नॉट? सो इफ द विंडो साइज इज 1 देन द चैनल यूटिलाइजेशन इज दिस. भाई आप लोगों ने क्लास 1-2 में पढ़ा होगा ना कि एक पेन का दाम अगर 5 रुपया है तो 10 पेन का दाम कितना होगा, 50 रुपया. हाउ यू आर गेटिंग दिस? बाय मल्टीप्लाइंग. सो फॉर द सिंगल फ्रेम, if the channel utilization is this, then for the n number of frame, which is nothing but the sliding window protocol. So in case of sliding window protocol with window size is equal to n. So in case of sliding window protocol, the channel utilization will become n into TF upon TF plus 2. So it is understood that we are assuming the transmission time of the acknowledgement as a negligible. Okay, so this one will become the channel utilization in case of sliding window. So my dear friends, please try to understand. If the utilization of the channel is equivalent to 100%, so this implies 1 is equal to n into TF upon TF plus 2TP, and this implies n is less than equal to TF plus 2TP divided by. So here, what is the n over here? What is the n over here? Just see. What is the n over here? The n is the window size of sender. What is the n over here? This is the window size of sender for 100% utilization. So या तो विंडो साइज इसके इक्विवेलेंट हो सकता है. इक्विवेलेंट कब होगा? whenever the channel utilization is 100%, or it can become less than of this. It can become the less than of this, and that's why we are writing the value of n is less than equal to this. Are you getting my point or not? So in case of sliding window protocol, the maximum window size n is the window size for the 100% utilization, or you can say n is equal to, this is the maximum window size. So just see over here, ultimately we have written the formula eta of n is equal to n into TF upon TF plus 2TP. Now for 60% channel utilization, we are trying to calculate the value of n. So it will become 60 upon 100 is equal to n into TF upon TF plus 2TP. So it will become 3 and this one will become 5. So n is equal to is equal to 3 into TF plus 2TP and divided by 5 into, you can say n is equal to 3 by 5 TF plus 2TP divided by TF, and of course 3 by 5 is less than 1. 3 by 5 is less than 1, so you can say the value of n is less than TF plus 2TP divided by, you getting my point or not? So that's why we are saying if the utilization lies between 0 to 1, this implies the window size is either equal to or less than TF plus 2TP divided by, got it? Utilization will lies between either equal to this or it will become the less than of this. So you can, according to the questions, you can utilize the options. If it is given as for the 60% utilization, you have to follow the 60%. If it is given for the 100% utilization, you have to follow the 100%. Or in another way, they will ask for the maximum utilization of channel. My dear friends, when we will utilize the channel in its maximum limit, whenever entire channel is occupied by the frames, it means the channel utilization is 100%, maximum means 100%. So the question will be given either for the 100% utilization or for the maximum utilization. Fine. Now, learning this, let's try to solve some of the numerical. See over here. See over here. This is the first numerical I am trying to solve. Consider a 10 Mbps link with the channel utilization of 60%. Fine. Network is using sliding window protocol. What is the maximum throughput of the channel? Now let's try to calculate the throughput of the channel. Let's try to calculate the throughput of the channel. So here we have calculated the utilization. In case of sliding window protocol, the channel utilization is n into TF upon TF plus 2TP. This is the channel utilization. First thing we have calculated, and second thing we have calculated is the value of n, that is the window size, is always less than equal to TF plus 2TP divided by TF. Okay, this is the second thing we have calculated. Either the window size will become equivalent to this or it can become less than equal to this. So the third thing is throughput. That is also known as effective data. So how you will calculate the throughput? Of course, if the window size is n, then how many bits will be transmitted? Because what is the definition of the throughput? The throughput is number of bits transmitted per unit time. Number of bits transmitted per unit time. So my dear friends, please try to analyze the situation. Suppose this is the window size. Suppose this is the window size and these are the frame inside the window. Okay, and what is the window size? This is given as n, and size of each frame is how much? The size of this frame, this particular frame, is L bits. Size of this frame is L bits, and again L bits. So how many bits we are transmitting? Total we are transmitting n into L bits divided by total time. What is the total time? TF plus 2TP. So it is given in second. So ultimately it will become n into L divided by TF plus 2TP. So this is the effective data rate, or you can say the throughput, and it is measuring into the form bps, that is the bit per second. Now I am trying to modify this particular formula. See over here, R effective is equal to n into L divided by R, and again multiply it by R. So again TF plus 2TP. My dear friends, what is the value of L by R? This is the TF. So we can write n into TF upon TF plus 2TP into R. And what is the value of this? This is nothing but eta of n. Already we have calculated over here. So just write it down. So it will become channel utilization for the window size n into this one will become the R. So inside the numerical, if all the parameter like the L, TP and bandwidth is given, then apply this formula. And if the channel utilization is given, then apply this formula. So according to question, you have to apply the formula one by one. So this is also measuring in bit per second. Of course, since the utilization is the dimensionless, because this value lies between 0 to 1. So ultimately the dimension of this, that is the throughput, is equal to the dimension of bit rate. Got it, everyone? Now keeping these things, you have to solve all the numerical. So just see the numerical over here. So here what is given? The bandwidth is given. This is the actual bandwidth, okay? And the utilization of the channel is given as 60%. And we are using the sliding window protocol. What is the maximum throughput of the channel? So in this situation, R effective, we will utilize the formula eta of n into R. So this is nothing but 60%. 60% means 60 divided by 100 into R. R is nothing but 10 Mbps. So 0 will become 6. And they are asking you the answer in the form of Mbps. So the right answer will become 6. The right answer will become 6. Got it? So in this manner, you can easily solve this kind of problem. Now let's see the next problem. Now let's see. The station A uses 100 bytes packet to transmit a message to the station B using sliding window protocol. Now the propagation delay between the station A and B. So make a diagram according to the question. There are two different stations, station A and station B. Okay. See, the station A uses 100 bytes packet. Means what is the frame size? L is given as 1000 bytes. Okay. The propagation delay between the station A and B is 80 milliseconds. Means the TP is given as 80 millisecond. Okay, and the bandwidth on the path is given as 4 Mbps. Bandwidth means data rate R is given as 4 Mbps. Now what is the optimal window size that the station A should use? Optimal means maximum window size that the station A should use. So to find out the maximum window size, we require the two parameter. One is the TP, that is the transmission time of a single frame, and second one is the propagation delay. So we have a propagation delay. Now calculate the TP. So how we will calculate the TP? Of course, how we will calculate the TF? Already we have a TP. So this is nothing but L upon R. What is the value of L is given? This is the 1000 bytes. Convert the bytes into bits. So 8 bits divided by bandwidth. It is given as 4 into 10 to the power 6 bits per second. So bits will be cancelled out, and by this it will be cancelled as a 3, and 4 to the, it will become 2 into 10 to the power minus 3 second it will become 2 milli. So here we are getting the value of TF. So my dear friends, the value of TP is 80 millisecond and the value of TF is 2 millisecond. Now, how to calculate the optimal window size? So N is always less than equal to TF plus 2TP divided by TF. So N is less than equal to 2 plus 2 into 80 divided by 2. Yes or no? So the value of N will become less than equal to 81. So what does it mean? Either you can take the maximum window size at 81 or you can take the window size equivalent to 80. Means you have to take the optimal value. If it is coming out to be 81, then either you can take 81 since the 81 is not inside the option. So you have to take the optimal of 81. So it will become the, so the right answer is for this question is, right answer of this question is C. Got it, everyone? Now to solve the rest of the questions, we require the concept of go back and selective repeat protocol. Now let's see what is the go back and what is the selective repeat protocol. So just see over here. See, the sliding window protocol is further categorized into two different parts. One is the go back and second one is the selective. Okay, GBN basically means go back and, it means go back and this one is the selective. This one is the selective repeat and sometimes we call the selective reset. Okay, so what basically happen in case of go back and selective repeat? So before understanding what basically happen in case of go back and selective repeat, let's try to understand some of the things. Now see over here, we are using a sliding window protocol, means there should be a sender as well as receiver. Okay, and the sender is created a window size. The sender is created the window size depending upon the channel capacity. Channel capacity means how many bits that can be accommodated inside the channel. Okay, so according to this, the sender has created its own window size. Okay, and this window size we are assuming the N. Now just imagine if the sender will transmit all the frame which is inside the window, and due to some reason any one of the frame will get lost in between the medium. Okay, so what will happen? How the sender will come to know which frame has been lost? Suppose sender एक 2 3 4 5 6 अलग अलग फ्रेम को रिसीवर को क्या कर रहा है, सेंड कर रहा है, एंड सपोज कोई एक पर्टिकुलर फ्रेम लॉस्ट हो गया, देन हाउ द रिसीवर विल एक्नॉलेज द सेंडर दैट दिस पर्टिकुलर फ्रेम हैज बीन लॉस्ट. भाई उस पर्टिकुलर फ्रेम के बारे में रिसीवर इंफॉर्मेशन कब देगा? जब सेंडर कोई लॉजिक यूज करेगा. क्योंकि आप इमेजिन करो कि मेरे पास 6 बंदे हैं और 6 बंदे में से सभी का मैंने जो सर है वो अलग कर दिया है. मीन्स यू कैन नॉट रिकॉग्नाइज एनी वन बाय देयर हेड. ठीक है ना, और सारे बंदे को मैंने व्हाइट शर्ट पहना कर करके सेंड कर दिया आपके पास, उसमें से कोई एक लॉस्ट हो गया है, तो आप कैसे इंडिकेट करोगे कि कौन सा लॉस्ट हुआ है? भाई मैंने 6 को भेजा, आपको मैंने नहीं बताया कि मैंने कितने को भेजा है, और सपोज आपके पास 5 ही पहुंचा, तो आप क्या सोचोगे कि भाई लगता है कि सेंडर ने 5 ही मुझे सेंड किया था, तो आप मुझे 5 का एक्नॉलेजमेंट सेंड बैक कर दोगे, यस और नो? बट in this situation neither the receiver is able to know which person has been lost, and that's why the receiver is unable to inform the sender, क्योंकि सभी को मैंने एक व्हाइट कलर का टी शर्ट पहना कर करके सेंड कर दिया है। लेकिन ये पहला सिचुएशन हो गया जहां पर सेंड रिसीवर जो है वो कैपेबल नहीं है ये इन्फॉर्म करने के लिए कि फ्रेम लॉस्ट भी हुआ है या नहीं हुआ है, पर्सन लॉस्ट भी हुआ है या नहीं हुआ है। दूसरा सिचुएशन क्या है कि सपोज सेंडर किसी भी फ्रेम को सेंड करने से पहले उसको मार्क कर रहा है, दैट इज द 0 1 2 3 4 एंड 5, and suppose the receiver is receiving the frame in this manner, सबसे पहले 0 रिसीव हो रहा है, फिर 1 रिसीव हो रहा है, फिर 2 रिसीव हो रहा है, फिर 4 रिसीव हो रहा है, देन 5 रिसीव हो रहा है। तो by looking upon this number series, by looking upon this number series, the receiver is able to realize that frame 3 is, are you getting my point or not? Looking upon this number series, the receiver is able to realize that the frame F3 is lost. So immediately the receiver will inform the sender that retransmit the frame F3. तो यहां पर अब रिसीवर सेंडर को क्या कर पा रहा है, इंफॉर्म कर पा रहा है। और ये कब पॉसिबल हुआ, जब सेंडर ने हर एक फ्रेम को मार्क करके भेजा था। क्या करके भेजा था? यूनिकली मार्क करके भेजा था। यहां पर ये टर्म्स बहुत ही इंपॉर्टेंट है, यूनिकली मार्क कर करके सेंड करना। ओनली इन दैट कंडीशंस द रिसीवर विल बी एबल टू इंफॉर्म द सेंडर दैट दिस पर्टिकुलर फ्रेम हैज बीन लॉस्ट। सो टू हैंडल द एरर, एरर का मतलब क्या होता है, किसी भी फ्रेम का या एक्नॉलेजमेंट का लॉस्ट हो जाना, ठीक है ना। टू हैंडल द एरर द सेंडर हैज टू मार्क ईच एंड एवरी फ्रेम बाय द यूनिक नंबर। ओके, so what I am trying to say, just see over here, to handle error means loss. To handle the error, the sender has to mark each frame uniquely by some number, numbers, and that is known as सीक्वेंस नंबर। इसको हम लोग एक नाम देते हैं, क्या नाम देते हैं? सीक्वेंस नंबर। व्हाई द नेम इज गिवन एज सीक्वेंस नंबर? क्योंकि हम लोग सीक्वेंशियली मार्क करते हैं। कैसे मार्क करते हैं? वी बेसिकली मार्क ईच एंड एवरी फ्रेम इन अ सीक्वेंस मैनर, लाइक 0 1 2 3 4 5। ऐसे आप मार्क नहीं कर सकते हो फ्रेम को, आप ऐसे मार्क नहीं कर सकते 0 1 4 7 8 9। यू कैन नॉट मार्क लाइक दिस, क्योंकि ये जो मार्किंग है ये सीक्वेंस फॉर्म में नहीं हो रहा है। सो दिस मार्किंग इज नॉट अलाउड। आर यू गेटिंग माय पॉइंट और नॉट? सो यू हैव टू मार्क द यूनिकली। यहां पर भी यूनिकली मार्क हो रहा है, लेकिन ये सीक्वेंशियली नहीं हो रहा है, एंड दैट्स व्हाई वी आर सेइंग इट इज कॉल्ड द सीक्वेंस नंबर, बिकॉज वी आर मार्किंग ईच एंड एवरी फ्रेम सीक्वेंशियली, ठीक है ना। तो सीक्वेंशियली फ्रेम को मार्क करने के लिए मुझे बिट्स की जरूरत पड़ेगी, तो उसको हम लोग बोलते हैं, ठीक है ना, how many bits required to mark each frame uniquely 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 inside window of साइज n। अगर विंडो का साइज n है तो कितने बिट्स चाहिए होंगे हर एक फ्रेम को यूनिकली मार्क करने के लिए? माय डियर फ्रेंड्स, इट विल बिकम log of n on the base 2 selling value, yes or no? So these number of bits we will indicate by small m. So this is nothing but m is equal to log of n on the base 2 selling value. Got it? So what is m over here? m is called sequence number. Take example. सपोज अगर विंडो का साइज n का साइज सपोज 10 है तो 10 फ्रेम्स को यूनिकली मार्क करने के लिए कितना बिट्स चाहिए होगा आपको? 4 बिट्स। हाउ यू विल गेट log of 10 on the base 2 सेलिंग वैल्यू क्या आएगा? log of 10 on the base 2 का वैल्यू कितना होता है? 3.2। तो 3.2 का सेलिंग वैल्यू लेंगे, 4 बिट आ जाएगा। सपोज n is equal to वी आर कंसिडरिंग 25, तो 25 फ्रेम्स को यूनिकली मार्क करने के लिए कितना बिट चाहिए? 5 बिट्स। एंड हाउ यू विल अचीव दिस? तो log of 25 ऑन द बेस 2 सेलिंग वैल्यू, तो 25 log बेस 2 का सेलिंग वैल्यू कितना होता है? 4.7। 4.7 का सेलिंग वैल्यू कितना होगा? 5। तो इट विल बिकम 5। So in this manner we can easily calculate the sequence number bit to mark each and every frame inside the window. Now considering this concept, we will try to deal the go back and selective repeat. See over here. See, in case of go back and, of course कम्युनिकेशन में सेंडर है और रिसीवर है, तो सेंडर का भी अपना विंडो साइज होता है और रिसीवर का भी अपना विंडो साइज होता है। दिस इज द सेंडर। टू स्टैब्लिश द कम्युनिकेशन वी रिक्वायर द सेंडर एज वेल एज रिसीवर। तो सेंडर के विंडो साइज को हम लोग इंडिकेट करेंगे SW से। SW मीन्स सेंडर विंडो साइज, एंड यहाँ पर इंडिकेट करेंगे RW से। RW मीन्स रिसीवर विंडो साइज। सो माय डियर फ्रेंड्स, इन केस ऑफ गो बैक एंड प्रोटोकॉल, द सेंडर विंडो साइज is always taken as less than 2 to the power m, and the receiver window size is always considered as 1, where this one is the sender window size and RW means receiver window. Got it? So always remember this. देखिए इसके पीछे भी लॉजिक है, ठीक है ना? ये ऐसे ही हवा में नहीं आ जाता है कि सेंटर विंडो साइज हम लोग लेस देन 2 to the power m ले रहे हैं, तो देयर इज अ लॉजिक बिहाइंड दिस। एंड व्हाट इज द m ओवर हियर? अभी मैंने बताया था m इज नथिंग बट सीक्वेंस नंबर। Okay, similarly in case of selective repeat protocol, the sender window size is equal to receiver window size is less than equal to 2 to the power m minus. So in case of selective repeat protocol, the sender window size always be considered equal to the receiver window size, and this is less than equal to 2 to the power m minus 1. So there is a reason for everything, why we are considering this and why we are considering this. Okay, so today we will discuss some numerical related with the go back and the selective repeat protocol, and in the next lecture, means in a part 3, I will tell you why I am considering the center window size and the receiver window size like this. You will get the complete explanation of this, don't worry. Okay, see, sender window size. तो भाई विंडो साइज को अगर यहाँ पर दिया हुआ है सेंटर विंडो साइज लेस देन 2 to the power m, इस बात को ध्यान से समझना। तो सेंटर विंडो साइज को हम लोग कैसे इंडिकेट करते हैं? Suppose here, just see, see what I am considering. Suppose sender window size is equal to, we are considering the center window size is equal to n. So what we can write from here, this is the n less than 2 to the power m, take log on both sides with base 2. So log of n on the base 2 is less than m. Now you can write this is the m is just greater than log of n on the base 2. Okay, we have to take the least minimum value of m. We have to take, see my dear friends, what I am trying to say, please try to understand. See over here, see over here. सपोज अगर सेंटर का विंडो साइज 25 है, सेंटर का विंडो साइज 25 है, तो इसको रिप्रेजेंट करने के लिए जो सीक्वेंस नंबर बिट्स होंगे, ये हम लोग 5 बिट से भी यूनिकली मार्क कर सकते हैं. ऑफ कोर्स अगर 5 बिट से कर सकते हैं तो 6 बिट से भी कर सकते हैं, 7 बिट से भी कर सकते हैं, एंड अप टू डॉट डॉट डॉट. सो आउट ऑफ विच इज द मिनिमम वैल्यू. ऑफ कोर्स दिस वन इज द minimum bits, minimum number of bits required to represent sequence number filled, sequence number filled, yes or no. ऑफ कोर्स 25 को रिप्रेजेंट करने के लिए मिनिमम 5 बिट्स से हो जाएगा, यूनिकली मार्क हो जाएगा, 6 बिट से भी हो जाएगा, 7 बिट से भी हो जाएगा, तो मैक्सिमम का कोई लिमिटेशन नहीं है. एंड दैट्स व्हाई द गेट ऑलवेज यूज्ड टू आस्क फाइंड द मिनिमम नंबर ऑफ बिट्स टू रिप्रेजेंट द सीक्वेंस नंबर फील्ड. आर यू गेटिंग माय पॉइंट और नॉट? सिमिलरली we will apply the same concept over here. So my dear friends, suppose विंडो का साइज n is equal to 25 है, तो 25 का अगर हम लोग लॉग लेते हैं विथ बेस 2 में, तो ये वैल्यू कितना आएगा? इट विल कम अराउंड 4.7, और कोई भी नंबर ऑफ बिट्स फ्रैक्शन में नहीं हो सकता है. सो इस इनइक्वालिटी को अगर हम लोग रिमूव करें, इस इनइक्वालिटी को रिमूव करें, तो यहां पर m क्या हो जाएगा? तो ऑफ कोर्स इसका अपर वैल्यू लेंगे, तो व्हाट इज द अपर वैल्यू ऑफ दिस? दिस इज द 5. So if we are considering the upper value and we have to think about the greater than this, so it will become equal to selling value log of n on the base. Are you getting my point or not? And this one will become least value, or you can say minimum value, minimum, क्योंकि भाई ग्रेटर देन n है तो मैक्सिमम तो आप कुछ भी ले लो, कोई फर्क नहीं पड़ता, ठीक है ना. लेकिन ये हमारा लिस्ट वैल्यू जनरेट हो रहा है, मींस लिस्ट इंटीजर वैल्यू वी आर गेटिंग ओवर हियर. सो इन केस ऑफ गो बैक n वी विल अप्लाई दिस पर्टिकुलर फॉर्मूला, एंड इन केस ऑफ सेलेक्टिव रिपीट प्रोटोकॉल, सी ओवर हियर, इन केस ऑफ सेलेक्टिव रिपीट प्रोटोकॉल द सेंडर विंडो साइज इज लेस देन इक्वल टू 2 to the power m minus 1. This is n, window size is n less than equal to 2 to the power m minus 1. So take log on both sides. So log of n on the base 2 is less than equal to m minus 1. Just remove this inequality. तो इस inequality को हटाएंगे तो m minus 1 will become equal to log of n on the base 2 telling value. So this is the list value we are getting. So this implies m is equal to log of n on the base 2 telling value plus, so ultimately here we are getting the sequence number bit is equal to log of n plus 1. So these things we are getting in case of go back and protocol, and these things we are getting in case of selective repeat. So just remember this result that we are deriving with the help of things which is applying in case of go back and as well as selective repeat. Now let's solve the so let's see first numerical. Okay, see over here what the question is asking. The maximum window size at the sender in go back and protocol with m bits sequence number field is. So my dear friends, we know the maximum window size is less than 2 to the power m. So अगर हम लोग maximum value लेंगे तो n will become equivalent to 2 to the power m minus 1. Yes or no? भाई आप सोचो ना कि अगर m का वैल्यू सपोज 3 बिट्स है 3 बिट्स है मीन्स the value of n should be less than 2 to the power 3 means the value of n should be less than 8. तो इक्वल लेंगे तो कितना आ जाएगा 7 ही आएगा ना. So whenever you are removing the inequality then it will become 2 to the power m minus 1. So the right answer will become with this one will become the right answer. C will become the right answer. Got it? So this is the level 1 question. ठीक है ना, बहुत ही बेसिक सा क्वेश्चन है और इस तरह के क्वेश्चंस लेवल 1 में आते हैं. Now let's see the another problem. Let's see one more problem. Okay, see over here. This is the problem. So my dear friends, once again I will tell you, to get the subscription you can use the code IFA and you can get the subscription in case of plus as well as iconic. So the iconic gate has some additional features rather than the plus. Okay, for the more details you can visit to the our download the app and you can visit to the GATE ESE competitive exam. So you can get the information about the plus as well as iconic, and if you want the details information you can watch my video from the beginning. There I have already mentioned what is the plus and what is the iconic. Okay, let's see the numerical. Suppose the speed of the signal is this one. This one actually given as 2 into 10 to the power 8. Here, so the speed of the signal is this and the distance between two connecting nodes is 100 kilometers. So just draw the diagram according to the question. This is the node A and this is the node, and distance between these two nodes is 100 kilometer. Okay, and speed is given as this. So here we can calculate the TP. What will be the TP? TP is distance by speed. So distance is 100 kilometer. Convert the kilometer into meter. So 10 to the power 3 meter. So this one will become 2 into 10 to the power 8 meter per second. So meter will be cancelled out. So here you can see 5 number of 0. So it will become 3. So ultimately it is coming out to be 0.5 milli. Now the supported bandwidth in this network is 100 Mbps, means the bandwidth, that is the R, is given as 100 Mbps. Okay, and the frame size is 1000 bytes. Frame size means L is given as 1000 bytes. So you can calculate the TF. If R and L is known, you can calculate the TF, that is the L upon R. This implies 1000 bytes. Convert the bytes into bits. So it will become 10,008 bits divided by 100 Mbps. M means 10 to the power 6 bits per second. Bits will be cancelled out. So by this 30 you can remove over here. It will become 3. Yes or no? It will become 3. Now it is coming out to be 8 divided by 100 into 10 to the power minus 3 second. So this is coming out to be 8 divided by 100 milli second. Clear everyone? So TP we are getting the 0.5 millisecond and TF we are getting the 8 divided by 100 millisecond. Now what the question is asking, please try to understand. If the network is using the go back N protocol with no packet loss, find maximum window size if the channel is used its full capacity. So my dear friends, whether see over here, whether we are using the go back N protocol or the selective repeat protocol, both are the part of sliding window protocol. Okay, both are the part of sliding window protocol. So the channel utilization in case of go back N and SR will remain same. There is only one difference of the sender window size. Decision of the sender window size is differing between the go back N and selective repeat. Otherwise, the channel utilization which we have calculated in case of sliding window, that will be applied in both the cases. So just see over here. So for the maximum window size, whenever the maximum window size will be created for, see over here, for maximum window size, the value of eta should be 1, means the channel utilization should be 100%, means already we know the eta of N is equal to N into TF upon TF plus 2T. So this implies value of eta is equal to 1. So 1 is equal to N into TF upon TF plus 2TP, and this implies N is equal to TF plus 2TP divided by, this implies, what is the value of TF we have calculated? This is nothing but 8 upon 100 and plus, this is the 2 into TP 0.5 divided by again 8 upon 100. So of course this one will be deducted and here 100 will be multiplied. So this one will become 1. So ultimately we are getting 8 plus 100 divided by 8. Ultimately it will become 108 divided by 8. So just divide it. So whenever we will divide the 108 by 8, so 8 1 ja will become 28, 8 4 ja, sorry, 8 3 ja 24. Again it will become 4.0. So it is coming out to be 14.5. So what we are getting over here, we are getting the value of window size equivalent to 14.5. It means this is equivalent to 40. This is equivalent to 40. So the right answer will become the window size is equal to, my dear friends, if they are asking the range answer in the GATE questions, if they are asking the range answer, so the range answer will vary between 13 to, either you can answer the 13 or you can answer the 14, both will be considered as a true. Okay, so the right answer of these questions here will become, so I hope you people have got the idea how to solve this kind of questions. So my dear friend, that's all for today. This is the series. If you want to learn more about the flow control protocol, you have to watch the part 1 as well as the part 2. And today I have covered all the things related with the flow control protocol. So once you will attend the 2 days of lectures that I have taken in the last day and today, you are not going to make any mistake in your GATE exam related with the flow control protocol. And every year at least one questions will be asked in this particular, from this particular chapter. So learn it, gain the 1 or 2 marks in your GATE exam by learning or by attending only 2 days of classes. So that's all for today. Good night everyone, take care. And before the leaving the session, again and again I will tell you, never forget to use the code IFA to get the minimum 10% discount. If you want to get all my upcoming video lectures, then press the bell icon button for all the notification. Subscribe this channel, don't be late. Because once you will subscribe the channel, you will be able to access all the upcoming video lectures taken by the different faculty, and put your valuable comment, because your one valuable comments will save a lot of time for other student. क्योंकि बहुत बार क्या होता है कि YouTube में बहुत सारे वीडियोस होते हैं, लेकिन वो वीडियोस यूजफुल नहीं होते हैं, कहीं कॉन्सेप्ट गड़बड़ होता है, या कहीं पर वो पूरा नहीं होता है, या कहीं पर वहां पर उसका कोई स्टैंडर्ड नहीं होता है। तो इसकी वजह से होता क्या है कि जो स्टूडेंट क्लास अटेंड करते हैं, मीन्स वो पूरा क्लास कर लेते हैं, उनका टाइम भी बर्बाद होता है और वो कुछ सीख भी नहीं पाते हैं। और यही रीजन होता है कि मैं बार बार अपने स्टूडेंट्स को बोलता हूं कि आप अपने वैल्यूएबल कमेंट्स को यहाँ पर पुट अप करिए, so that the other student will get the awareness whether they have to access the lecture or not. And at the last moment, I will advise you one more thing. If you have any query regarding the subscription or the doubts, you can personally text me on my Telegram number, that is the 92649545. Thank you everyone. Take care. Bye. Good night. मस्त रहिए, मेहनत करिए, लाइफ में आगे बढ़िए।